Hey guys, welcome to System Design Fight Club. Today we are going to be covering a problem that is actually taken from a real interview question that has been given to staff or principal engineers. It's a traffic violation detection service, which is basically you've got these traffic cameras all over the place in the city. You've probably actually seen some real ones before where they're just like they're like a red light camera or something. And we're going to set up a system that like automatically detects vehicle collisions exceeding a speed limit, running a red light. I've taken a crack at this a couple of times before, just personally trying to sketch it out. It's the this requirement. This one's trickier. This one's trickier. It's explicitly in the prompt. It's described that you need to have pictures from multiple cameras for it. So it's usually a little bit trickier. I'll take a crack at it hopefully today. These are real numbers from the prompt that I've seen posted a couple of places. I've actually seen it posted on Leak Code discussions before, so I thought this was fair game for leaking now. So the numbers they usually provide are there'll be thousands of cameras throughout a city. They're spaced at about 500 meters, images at a rate of 10 per second, 20 kilobytes per image. An important number regarding this is that there's this thing called a packet of death. It's the limit for a packet to be sent over the network is 64 kilobytes. I'm going to make a note of that. Packet of death is 64 kilobytes. I have that in the README channel on the Discord somewhere. It's just a nice little fact to know for scaling numbers, but that after you exceed, you can't send a packet that's bigger than 64 kilobytes, basically is what that means. Continuing with the prompt, there will be a black box service available that takes in a set of images, and then it returns a violation type, some vehicle plate numbers, if it has one. And then what you want to do is send this control room thing where the violation occurred, the vehicles involved, and trace it back to a set of images of the incident. And it must be able to scale up as more cities are added. So I said thousands to a city. We're going to have multiple cities and it will be growing. And so I got those again over here. Are there any questions before I continue with this prompt? Or you guys all understand so well, all right so far? All right, I'll keep going then. I usually like to go for the numbers next. The numbers, I'll actually go ahead and go into the numbers in this case. It might be useful to go ahead and draw a very high level diagram though, just to make sure that we don't get totally lost here. So I'm going to have the cameras. This is going to be a client. We're going to call it a client. I don't know if it's completely fair to call the cameras a client. They're like a endpoint device. They're not servers. The cameras are of course not servers, and so that's why I want to have them with the same green box. They're a Internet of Things device, a smart device. So I kind of want to mark them in the same way that I like to annotate a browser usually. And we're going to have this thing called the control room. And I guess we can go ahead and call that like a browser. And I actually like those getting split like that. There we go. Just got a control room. We got the cameras. We're going to get something in from the cameras. And our goal is to get it all the way to, let's make this like that. Okay. We want to get it from the cameras all the way to the control room if there's an incident. That is our goal. And we're going to have a black box service. I'm going to actually add a little thing for the black box service as well. And I'm just going to call it the black box service. There we go. And we're going to have some kind of other backend services in there as well. I like to have custom components or very specially like external services I particularly like to have like in an orange box to indicate that they're different and special in some manner. I think that's good enough for context on where we're going and what we want our end result to look like here. So I can go ahead and look at the back of the envelope estimates. So we had tens of cities. Let's get okay, how much bandwidth per second per camera? How many cameras? And how much bandwidth total are those images going to be taking? And this will be a key piece of how we're going to handle getting those images like stored somewhere. This will be for determining what our scaling constraints are going to be. So we have we're going to say 20 cities, and we have 5,000 cameras per city, which comes out to 100,000 cameras in total is what our current setup is. How much bandwidth per second per camera? We have 10 frames per second times 20 kilobytes per image. So that comes out to 200 kilobytes per second per camera. And so then we're going to multiply these together, and then we'll get our final number for how much bandwidth we're going to need for this whole thing. It comes out to 20 million kilobytes per second, which is equal to 20,000 megabytes per second, or 20 gigabytes per second. And then internet speed, I've usually seen measured in gigabits, even on AWS's specs for their EC2 instances. I think it's like a special marketing tactic to rip you off really subtly. So you're actually going to multiply this by 8 to get gigabits per second. So we have 160 gigabits per second. An EC2 instance can handle up to 10 gigabits per second. My own internet connections, it's more common for consumer internet connections to be like 1 gigabit. So our one Ethernet cable, we will be able to handle about 1 gigabit to it's like 1 to 10 gigabits per second. So that would mean we're likely going to be bandwidth bound here. It's going to be like if we're actually getting a full 10 gigabits per second per EC2 instance, that would still mean we would need like 16 EC2 instances. And so I'd rather not like if that'd mean that we're bandwidth bound. That would definitely mean that we're bandwidth bound. So we actually do not want that to go through our services. We would rather have that not touch our services. We'd rather have it like do like a direct upload straight to the S3 buckets that we could stick the images in. Otherwise, it's going to become bandwidth bound. How many requests per second are we receiving though? It was that many cameras times 10 was 1 million TPS. That still is like a really high. I think we would end up like request bounds then. Okay, that's really fascinating. Okay, yeah, let's say what's our write TPS from the cameras? And I just did that out loud here. So that gets us 1 million TPS. I think that might actually be the constraint here. It really depends on how you write the code, but that sounds a lot more like a constraint here. I think you should still not have the images coming over the network. That still seems like it's very easy to just do a multi-part upload instead. Oh, and then how much are we going to store over the course of a year? So how much storage do we need for a year? That's also going to be a really important number. So we had 200 kilobytes per second per camera. It was, we had how much per second in total was 20 gigabytes per second in total. Across the thing times 100,000 seconds in a day times 365 days in a year. So we have 20 gigabytes per second in total times 100,000 seconds. That would get us to 2 million gigabytes per day times 365. So that gets us to about 700 million gigabytes per year. So it's looking like we're probably going to want to do some kind of cleanup job to not have all that just aggregating up all over the year, and just flag the ones that we actually do want to keep. 630 petabytes. Thank you. There's a question in the chat. Do we actually need to store all images instead of just images with traffic violations? So that's what I was getting at with doing a cleanup job, is that you know, after the images are done getting processed, I'm thinking we can go ahead and if there's no violation type returned by an image, we can go ahead and have it clean up the images. So that could be like a daily cleanup job, or like a weekly one. Actually, how much is it in a day? So it's 2 million gigabytes in a day, 2,000 2K terabytes, so 2 petabytes per day. Yeah, so at least once a day, we were probably going to clean. I think you can get an S3 bucket to be up to like 6 petabytes or something. But you're going to want to be cleaning up you're going to be running this cleanup job at least once a day, it's looking like. Yeah. All right, I think we can go ahead and start jumping into the diagrams, because I'm already kind of thinking ahead of myself a little bit. I got another comment in the chat. Do cameras click pictures when there are no vehicles? Traffic could be reduced during nighttime. I'm imagining they do. I'm imagining they're going to keep clicking pictures even when there's no vehicles, because so I like this black box service term for this thing. It's not actually in the prompt. It doesn't actually describe it as a black box service in the prompt, but it's going to be some kind of like machine learning model. I imagine that's going to do computer vision. And I don't think you'd have well, so you could put computer vision on the cameras themselves. Well, so the prompt was phrased that this was a service. It, of course, would have been a much more convenient, where was it? There it is. Yeah, it was phrased in the prompt as a service instead of having that machine model like directly onto the cameras. So if you don't have that machine learning model directly on the cameras, it's not going to know whether or not the picture is going to contain a vehicle. So you would, of course, have to have these images all the way through the service, the black box service, in order to properly determine whether or not there's a vehicle there. There's no way to figure that out just on the vehicles, unless you also added pressure plates or something, or some other tricks like that. There's nothing like that in the prompt, though. I think we just kind of have to work with what we're given. That would, of course, make for a really nice and interesting conversation with the interviewer, but I'm imagining it's going to be stuck with these constraints and minimize hardware costs. Okay, any questions before we try and hop into the diagram here? Last check. Okay, well, feel free to go ahead and post any in the chat as I keep going here. Okay, so we are definitely going to need to have some kind of object storage, at least temporary, for those pictures. So it's going to be the image object store. You're definitely going to need that. And then if the images were larger, like 2 megabytes instead of 20 kilobytes, you would definitely need to do a multi-part upload, which is where you like talk to this, and then this thing fetches a pre-signed URL from the image object store, and then it returns it back to the client, and then the client does a write over to, and then the client does a write directly to the S3 bucket over that pre-signed URL. So if the images were larger, you would definitely need to do that. We might be able, also having that conversation about like whether or not we were actually bandwidth bound. And it's looking like we might actually be like request bound or CPU bound. But I'm still feeling pre-signed URLs. It's maybe they wrote the backend in Erlang or something, and so you can actually get away with doing like tens of thousands or hundreds of thousands of requests per server. I know WhatsApp uses Erlang to handle a massive scale like that. So maybe you can do something like that over on the back end. And so then it would actually make sense to keep this from becoming bandwidth bound. So this will be the image. I can't think of a better name for this right now, but we're going to call it the image capture service. Anyways, you get the pre-signed URL, you hand it over here, they do the upload to the pre-signed URL, and then they send you an ACK. And then it's like, okay, they've uploaded the S3 instead of me, they've uploaded to S3 instead of me having to do that. And now I can do my other stuff. And so then you would capture metadata on, so this is going to be the image metadata data store. And so that one's S3, this one's going to be a regular database. You do not, I think you really do not want to have the images stored as blobs directly within the database. I think that's a really bad idea. And then you can also do event sourcing probably on this. You might be able to do event sourcing since the individual records over here are a lot smaller. So you're going to write the record over there, and then we're going to send it downstream, and we're going to want to do some kind of processing at some point with these images. I definitely want to talk about the schema here. It's going to be interesting for sure. I still can't believe it was 1 million TPS on this. I've looked at this a few times before, but I did not recall it being 1 million TPS. That's actually like a really high scale for this problem. And so then you actually have to worry about you're like not hosing your partitions in certain ways, or maybe even the key range queries. Very interesting. Okay, so after you write those, you're going to be needing to send, you're going to need to process these images with the black box service. So sending that message downstream for like, hey, I've got a thing ready for processing. You can either do like a DB trigger per image, or you could do, I've definitely seen DB triggers that can scale over thousands of TPS. DynamoDB actually can handle, apparently the DB triggers on DynamoDB are totally solid. Another option would have been to have a message broker between them. So there's a couple of different ways to handle the event going further downstream. I think I'm just going to go ahead and go with a DB trigger. And then we're going to have this thing. It's going to talk to the black box service, get a response. And then if it's violation, we can store it over there. Yeah, so we're going to have another service that's just going to kind of be coordinating. I don't know if coordination is really the right word. It's just kind of doing the violation processing. So violation processing service or image processing. It's going to run some stuff through black box service. And then with the response, if there is any issues with, if there are any violations recorded, we're going to want to store that in a violation database. It's going to have a violation DB over here. Okay. And then the cleanup job does not have to happen as well as a response directly following each individual request. That would be like 1 million things running for doing a cleanup job every single second. So instead, I think you can just have it as more of like a batch job style thing that's scheduled to run once a day, where you're just going to look at the violation DB. We should probably start talking about the schema around, we should definitely start talking about the schema here soon, but you would be looking for what images from here are not over here, what's not tied to violation. And then you would be able to just take those and clear them out of the object store. I got a question in the chat. wouldn't the DB trigger show when the pre-signed URL was generated and not when the image was actually uploaded? Wouldn't the DB trigger show when the pre-signed URL was generated and not when the image was actually uploaded? Okay, so I think you can, it depends on when you store it. You can store the pre-signed URL before doing the ACK, before the ACK happens, or you can put off recording the metadata at all until the ACK from the client. If you do the latter, where you put off doing anything until after the ACK from the client, then you could possibly get some dropped. We could, of course, have an unreliable network where we just never get the ACK and we never properly did that. Yeah, let's talk about the schema a little bit over here. So you would of course want to have the pre-signed URL stored in the image metadata DB. So you have pre-signed URL is going to be one attribute, and you could have, I guess, a status. And so then I guess you could go ahead and, well, so even if you store the pre-signed URL before you hand it off to the client, you could have your server could get the plug pulled on it between receiving the pre-signed URL from S3 and storing it over here. So I guess there still might be some risk there, I think. I haven't looked into too intimately into how the interactions work with getting the pre-signed URL, but I feel like there still would even be a little risk of it getting dropped, even if you just immediately stick it there. And then of course with the DB trigger, there's that. And so we can go ahead and wait for the ACK from here. It means that we'd have a bigger risk of dropped pre-signed URLs that just never get that ACK. But it's there either way. Maybe this is a thing we could return to later on in the video. So I'm going to put off the write to the database until we get the ACK from the camera. And then we'll go ahead and put it over here. And then I guess we wouldn't even need to have a status on each record. We can just go ahead and just each record would then be immutable. Let me write this. It's 3. It's going to look something like this. Slash my bucket. My bucket slash my object file name. Okay, and you would have a timestamp. We're going to need a timestamp on each of those. It's like 137,000,000,050,000 is roughly how those usually look. Actually, I think it's a 6 closer to today. And then we want the location. So we'll have lat launch. Just spell it all out. Okay, so it's going to look like that. Sure. Okay. So we have those, or we could have a camera ID. I think a camera ID is also going to help. So it could be camera number 784. And there's only thousands of these. I don't think we have to really worry about UUIDs. It can be a very manual process of adding a camera. I don't really want to worry about the camera process. It wasn't really a focus of this problem. So we're just going to say that they're an int for each camera ID. Okay. Right. And then we're going to have some kind of special key range queries where I think you can go ahead. So the red lights, I think, are rather easy, where you would pass just all 10 from a certain second into the black box service. So for the For the red lights, it's easy. You're just looking at the same camera ID. And so whenever you receive a new DB trigger, you can even filter it down to only consider the timestamps that are right at the top of a second or something. So you're going to probably do some kind of special key range queries to collect up on each DB trigger thing that's sent over to this thing gets hit by. You're going to have a special key range query constructed or specially formatted SQL query that'll return a certain set of image records from this at a certain spacing over the course of like 5 seconds or something. And then you would need to pull those from the object store and then pass them over to the black box service. It sounds like this one would not retrieve it directly from S3 on your behalf. So then we're going to want to have those pulled from the object store directly to the violation detection, the violation processing service. It's just going to have to read them directly from there and pass them over to the black box service. Okay, let's talk about the violation DB a little bit. Those queries to this database off the trigger are going to be really interesting. Maybe we can return to that. Okay, the violation DB. So we'll have a violation type. Is it just one? It's involved. Violation type, yeah, it's just like one. So you're going to have a violation type be something like excess speed, vehicle collision. We'll say red light. You're going to need a timestamp, I think. Okay, what all are we sending in the control room? Where the violation occurred, vehicles involved, and the set of images. I think you're still going to want to have, actually, we could have the list of the timestamps that the list of the images. You should, okay, I think you should have you have a UUID per image? Should we have like a UUID? So we have the timestamps per image. The timestamp is in seconds typically, and it takes 10 images per second. Okay, so that's like interesting, is like Unix epoch time is usually in seconds, then we're taking 10 pictures per second. So I think you're still going to kind of need to have some kind of image ID. And you can kind of construct that off of the camera. So it can be like 784 dash, and then you would just kind of, you could have the camera kind of attaching the image IDs or generating itself as it's sending them over. So we can have it like that concatenated with, you know, I do just kind of want to have a UUID, just a straight up UUID for these. And what you store over here could be a combination of the camera ID plus the image ID to make sure they're all actually unique. There's a question in the chat. Would it be advantageous to have a separate object store for violation related images? Then the periodic image deletion logic can be just a time range deletion. The two object stores can have different durability as well. I'm kind of liking the idea of that. I never like to do deletions on a database. I'm definitely a huge fan of event sourcing, and I'm the idea of having a separate violation image object store is definitely has an appeal to me. So then you could just you could maybe like spin up a new bucket every single day, because it's 2 petabytes per day, and that's literally just like a whole S3 bucket. Or you could have I don't know, you could have a bucket for each. You'd have a bucket for each city, and then like a folder for each day. And then the cleanup job is just deleting the previous day's bucket. And that way you don't have to worry as much about the logic of not deleting any images from today that are still getting processed, or if there's like an outage like at 11:50 p.m. or something, it would reduce the risk of deleting images that are still going through the violation detection processing. Yeah, I'm feeling that idea of having an image object store though. Sure. All right. Yeah. You can definitely get away with not doing that. That just totally appeals to me as well. Should probably record the thing about the folder structure that I'd come up with over there. You might need to have like a second database for the config of mapping a city to a specific S3 bucket or something. It'd be something really small though. I don't know if I should really even draw it. Okay. I was on the image IDs. All right. I guess you don't need, so each image could actually have a different timestamp. So you don't, so you wouldn't store the timestamp in this one. You would actually just need to have the image ID list. And they could come from different cameras. So it would be, I guess you can definitely do this in like DynamoDB is a list of objects. So you would have like, you have the camera ID of 784. And then you have the first object is this image. And then we're also going to have another one for, we're just going to have two records here. I won't go too far into it. 785. So it could be, you could have a different camera ID, just pointing that out one more time. And let's have 456, XYZ, DEF, EF, GHI. Sure. All right. So you need the image IDs, you need the violation type, vehicle plates. That's right. The black box service returns the vehicle plates. So you're also going to have a list of vehicle plates. Okay, it was how do those look? It's like ABC 1, 2, 3, 4. That's something that I think you'd have. I haven't looked at it. I haven't looked at my license plate in a while. I think they usually look kind of like that. Somebody go ahead and correct me if it's bugging you a lot. You remember how they're supposed to be formatted. I think it looks like that though. So we have vehicles involved. It could be multiple. For red light, it'd only be one. Yeah, so we're just gonna have that, but it should be a list just in case there's multiple people involved in a violation. Okay, what else do we need? Where the violation occurred. That's what you need in the control room. Okay. I'm thinking again about how much. Okay, it needs where it occurred. What if you have multiple different cameras? Do you really need multiple locations? Can you just go ahead and have the first picture from the set? You can just go ahead and store that, and then also use the timestamp from that first picture. And then that gives you like a rough estimate of the area and the time of day. So like, for example, if it's like Tuesday at 3 p.m. at some specific intersection where really it's them speeding across a couple of different intersections, but it gives you like a rough estimate. So I think we can go ahead and use just the timestamp and the location from just like the first image. Okay, so we got that, and then it was all the images were already passed into this. They're also going to be sent over here. And then we have the control room is also going to receive a notification. I want to talk about primary keys on these data stores at some point, because these objects are looking a little bit nasty. How is the control room going to be looking at, how are they going to be getting notifications? How are they going to get notified? So you can have it notify them and send them an email, but also have a web interface. I'd imagine that the control room would have a web interface, then also something like email or just like push notifications in the browser or something. You would need a notification service that's pushing notifications, whether they're emails or just in browser push notifications from like a WebSocket. A good number to have would have been how many violations we're getting per second, because right around on the outs end of the violation processing service, we're probably going to be seeing a much lower traffic volume, a much lower scale for our services. Anyways, we should have a notification service. Then we should also have a service that's supporting the front end that they might be using for the control room. So we're going to have a notification service over here. And we should also have a violation viewing service. Violation, what is it? Violation browsing service. Sure, that's what we'll call it. So they would be doing reads from this. This will be gathering up the violations for them. So that would be doing key range queries. So it could be violations of a specific city, just like ordered by time. So that would probably be a nice secondary index. Is by time, and then they just have lists of violations to go check out. And then we also want to have notifications. So whenever it picks up on a violation, it'll go ahead and send a notification over here. And then that could either be a WebSocket push straight to the browser, or it could also be their email. So I could do both. So browser, and then the violation service is going to do a WebSocket push notification, and it's also going to send an email. Yeah. Okay. We have a couple more things in the data store that we should probably, for the schema that we should deep dive. Definitely some indexes on these. We should definitely talk about indexes, particularly on this one. This one's going to be weird. Maybe it should just generate a new UUID every violation that it picks up. But I want to check if there's any questions before I keep going and trying to dig into the schemas on these. No questions? Okay, yep, I'll just keep going then. Okay, this one's the easiest. How are we going to do the primary key on this? It can be a combination of the camera ID and the image ID. I'm actually going to bump that up to the top since it's the primary key. And then how are we going to partition it? It's not really going to have any celebrity issues. I won't really have a celebrity problem. And then we're probably going to want to query by the camera ID for like certain images within the same camera ID for like a little time range. So that would even help with key range queries for that. You might even store like a city ID or something on this, and that could even help for if you're doing something across several cameras. I'm going to go with this for now as the partition key though. And then you could use the other one as the sort key. And then this would be good for a secondary index. And then depending on how in the heck you're going to be getting those nearby cameras and how those weird key range queries or specially formatted queries are going to look for calling the image database, image metadata database, you're maybe going to have both of these also indexed. If you just have, I'm trying to think if this is really going to be a geolocation problem. I don't think it is. You should just have it so that there's maybe a certain set of cameras that you check every time. So it's like more like a pre-cached output of, geolocation of the nearby cameras instead of having instead of trying to look up what cameras are nearby every time, then doing the time delta, whatever, to figure out whether or not somebody's speeding. So that's why I usually skip this, is like you need to have the nearby cameras, and then it's also like what time range apart are you going to be looking at those for. It's weird, but maybe this is it. It will probably be a nice secondary key. Okay, there's a question in the chat. In an image object store, do you prefer paying by per gigabyte of storage or pay by bandwidth usage, as in AWS Glacier tier? I think you have to pay by both. I'm not super familiar with that, but I think it just depends on whatever's the constraint that results in having to pay money. I'm pretty sure you end up having to pay by both, which reminds me, we also have to have that cleanup job. And so we're going to want to have some kind of daily thing that's going to come over, and it's going to, we can talk about the folder structures that you have. It's my city name, and then you can have it's date, and it would be you want year dash month day slash image UUID, or camera ID image UUID. Okay, and so these task runners are just every day they're going to clear out the ones from the prior day. And so, for example, if it's currently like January 7th, approaching midnight, delete all folders for January 6th. And that's to avoid issues from fraud issues resulting in unprocessed images. Okay. So we've got at least a pretty solid idea of what we want to do over here. Over here, what do we want to do for the primary key? Have a violation UUID. Yeah, you could probably just come up with a violation UUID. If you have a control, so it said one control room, it said control room. Yeah, so it said control room, not as in like control room per city, but like if you did have a control room per city, maybe you should have like a city ID. I want to go back and add that. And then we have my city is in there already. So I really think that we probably want to have a city name. So it would be like, for example, Seattle. I think it's just helpful to have, and you would just have it set up on the camera to always send that city ID in the message over to the image capture service. And then we could also have the city ID over here. And then even if you have a control room that spans multiple cities, like you have a East Coast control room and a West Coast control room or something like that, this also makes it a little bit easier to do that. Okay, and then I guess, oh, I still think I'd like to have a violation UUID. Yeah. As okay, and then so the primary key, I'm just going to use this one. And no, so do I want a sort key? Or we could have city ID as the partitioning key. That could even help. We could have city ID, the UUID, and the timestamp. Or no, this doesn't have to be a sort key. It's just this should be a secondary key. This should definitely be a secondary index. Okay, we have that. Yeah, I don't know. I just feel like city ID would make for a really good partition key. So we could have this as the partition key, and then the whole thing together is going to form the primary key. Okay, is there anything else that we should have as a secondary index? We could have violation, well, so violation types an enum. I don't know if you really need to have a secondary index on an enum. So it's like, I'd imagine that you have like a pages of violations just sorted by timestamp. They could maybe have specific violation IDs that they could pull up on like a violation detail page where it would actually have the images on that page. So when they're in the browser, if they look at like the violation detail page, they're going to want to be able to view those images on the browser. So that means that we're also going to have it. So again, with the way that pre-signed URLs work and just what you can do with S3 is that you are able to read directly from an S3 bucket. You can even host a static website entirely off of an S3 bucket. It's for very niche cases though. I've seen bigger websites though that are pulling like images and stuff just straight off S3, and that's totally like a valid thing. Posting a whole static web page off S3 though, that's like super niche. It'd be more likely that you'd have it hosted on a CDN than an S3 for larger websites. But yeah, you're gonna end up doing that. Okay, so are we getting everything we want for the control room? What else do they need to see? They need to see the where it occurred. We do have those there. Oh, we need to copy over the we need to store the so if we're going to be copying the images over to this object store when there is an actual collision or an actual instant, that means that we also need to store the URL of those images. The new URL needs stored somewhere. And so should we also have a metadata thing for that? Or I think you can just go ahead and structure the whole violation image object store the exact same way as this. Yeah, you could. Okay, and then you don't even, you would just need to have it's possibly going to have a slightly different domain, or like the bucket's going to be different. So it would be city name dash like violation bucket. Other one is just the capture bucket. But you would probably, would you need to store that too? I don't think so. It would, you could actually just have that as logic in this thing. So you're just keeping the UUID the same in both. Let's go ahead and have it stored over here too. Go over here. Have that. Yeah, okay. Cool. So this schema doesn't look as sketchy now. Okay, I see another question in the chat. I think I should just go ahead and post these questions straight over to the text file. That would maybe help people that are just watching the recording afterwards. A single instance of the violation processing service won't be able to handle that kind of bandwidth on a single instance. Is the idea to have a pool of these, and each is responsible for querying the latest images for a, so in the violation processing service, yeah, this would be multiple machines. This would definitely be multiple machines. So you have, I didn't talk about what technology we're going to use yet on these databases. That's right. That's another thing I need to cover. But this would be a distributed database. And then so each node, though, would have kind of like its own triggers. You somehow have these triggers that are coming off of it. And it's just not just like one machine, but it's I imagine it would be very similar to the way that Kafka works, because so Kafka is sharded. You have like shards of a Kafka stream even for a single topic, and then you can actually have DB triggers. No, sorry, you can even have AWS Lambda triggers listening to each individual Kafka shard, and so then it's really easy to set that up for that. So yeah, you can have it. You'd have multiple of these, and they're just listening for the DB triggers of whatever chunk of it they're assigned to. So yeah, multiple workers. Since of it won't be able to handle that. Yeah, you have a pool of it is responsible for querying the latest images and specific cameras. What if instead of a metadata DB, we used a partitioned queue to facilitate handing off work to a worker pool? You know, so that was the other means of change data capture that I was considering. So right now it's using DB triggers, and I should make a note of that. And then I want to also check out how this would look if we were doing the queue instead of DB triggers for the change data capture. So we can go ahead and just copy this whole thing. So this is just approach one. And then Steve-O from Life Engineer gives DB triggers a thumbs up though, by the way. He's I for months thought that DB triggers were too high overhead and too flaky. I was particularly concerned with triggers potentially being flaky, but he said he's had no issues with DB triggers ever being flaky, particularly on DynamoDB. So yeah, they're fine. Anyways, right, how are we going to make this look with a queue? So we've got that. This thing can get moved up a little bit. I'm just kind of making a little bit more space to play with this. Okay, so you can have the queue either here, and then you would have task workers copying to that, and then talking to this. And then that would also, yeah, that's what we're going to do here. Into that. And this is the read over here. This doesn't need to be so crazy far out there. But instead of talking directly to that, you could either do the write to the database and then you would talk to the message broker. But then what if you had what if there was like a dropped what if the plug got pulled between writing to the database and putting it on the queue? So I think you should just go ahead and talk to the queue directly. And then we're going to have some task runners that are going to read off of this. And then instead of having our okay, so we're going to be, we want to remove this. That's what we're removing. And then we're going to add in our task runners. And they are going to take it. So I'm sure I had something else for the image metadata. No, I didn't have that read anywhere else. Oh, that's right. I used to have it read directly by the violation browsing service in other cases where I did this. Okay. And then these are going to be Lambda triggers, just AWS Lambda triggers, and they do a pull off of the stream. And then they're going to do a write to this. It should be idempotent over the primary key. So the message is going to have just the whole record. We're just going to have the whole record in there. And it just dedupes off of the primary key. And so it sticks it there. And then as a second task, it will write over to the violation processing store. And so this is a way to do that without using DB triggers. So all I did was we had an arrow over here, and it used to be from image capture service to the image metadata DB. And then this was a DB trigger. We got rid of that, replaced it with this broker that does the copying to this and then over to here. Yeah, so that's how you use that's how you switch over to a partitioned message broker. Okay. I do not want to deep dive the queries and how that'll work for fetching a certain set of images spread across several cameras. I think I've covered everything that I've particularly wanted on this. It is really a hard problem. It's asked to staff and principal level engineers. There's probably certain things they deep dive a little bit better. Any other questions before I wrap this up? Okay. You guys can go ahead and drop off then. If you guys can think of any questions later, feel free to drop them in the Discord channel. We'll start a thread, of course, in the forum discussion channel as usual. Otherwise, I think I've handled everything that I can think of. Oh, shoot, I didn't handle the DB schemas or the DB technologies. Okay, so this one, you can either do DynamoDB or Cassandra. Works fine. I've been saying DynamoDB so much, and I think it has nice integration for DB triggers. That's why you would use it there. And then we're just going to go ahead and use the same thing over here for the violation DB. So I think that was already obvious, but I just wanted to make sure I did actually handle that. And then I think it's clear enough that I'm using S3 on these. Okay, now we're good. You guys are free to drop off. If you have any questions, feel free to drop it in the forum discussion channel on Discord. But otherwise, you guys are free to go. Thanks for joining.